Welcome to doassignment-ca. Here is the problem. A motorcycle starts from rest at s equals 0 and travels along a straight road with the speed shown by a velocity-time graph. The graph has three segments. From 0 to 4 seconds, v equals 1.25 t. From 4 to 10 seconds, v equals 5 meters per second. And from 10 to 15 seconds, v equals negative t plus 15. Determine the motorcycle's acceleration and position when t equals 8 seconds and when t equals 12 seconds. Now let us work through the solution step by step. The velocity time graph has three straight line segments. From 0 to 4 seconds, velocity rises linearly as v equals 1.25 t. From 4 to 10 seconds, velocity is constant at 5 meters per second. From 10 to 15 seconds, velocity decreases linearly as v equals negative t plus 15. Acceleration is the slope of each segment, and position is the accumulated area under the curve. At t equals 8 seconds, we are in the flat segment where velocity is constant at 5 meters per second. The slope of a horizontal line is 0, so the acceleration at t equals 8 seconds is 0 meters per second squared. To find position at t equals 8 seconds, we add up the areas of each segment from 0 to 8 seconds. The first segment from 0 to 4 seconds forms a triangle with base 4 seconds and height 5 meters per second, giving an area of 1/2 times 4 times 5, which equals 10 meters. The second segment from 4 to 8 seconds is a rectangle 4 seconds wide and 5 meters per second tall, giving an area of 20 meters. Adding both areas, the position at t equals 8 seconds is 10 plus 20, which equals 30 meters. At t equals 12 seconds, we are in the third segment, where velocity equals negative t plus 15. Differentiating with respect to time gives a constant slope of negative 1, so the acceleration at t equals 12 seconds is negative 1 meter per second squared, meaning the motorcycle is decelerating. For the position at t equals 12 seconds, we accumulate three areas. Segment 1, from 0 to 4 seconds, gives 10 meters, as computed before. The full rectangle from 4 to 10 seconds is 6 seconds times 5 meters per second, which equals 30 meters. For the third segment from 10 to 12 seconds, velocity drops from 5 meters per second at t equals 10 down to 3 meters per second at t equals 12. The area of this trapezoid is 1/2 times the quantity 5 plus 3 times 2, which equals 8 meters. Summing all three areas, 10 meters plus 30 meters plus 8 meters, gives a total position of 48 meters at t equals 12 seconds. To summarize, at t equals 8 seconds, the acceleration is 0 meters per second squared and the position is 30 meters. At t equals 12 seconds, the acceleration is negative 1 meter per second squared, and the position is 48 meters. The key principle is that, on a velocity-time graph, acceleration equals the slope, and displacement equals the area under the curve. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.